Let's write the population model using this exponential form. That is, P of t equals P naught n raised to the power of t by t. So here we are given that the tripling time is 4 months and initial population is 4,000. So we say that since the tripling time is 4 months, we say that n equals 3, and then this capital T is 4, and the initial population is 4,000. So we say that P naught, which represents the initial population, this is 4,000. So we plug all this value into this model. So therefore we get P of t. This equals P naught is replaced as 4,000. So it is 4,000 times n is 3. So I put 3 raised to the power of t, which represents the time, divided by capital T is 4. So I put 4 here. So this is the model which represents the population in the exponential form P naught n raised to the power of t by t. In fact, we can rewrite this as P of t. This equals 4,000 times 3 raised to the power of t by 4. We now write the equivalent exponential model of the form P of t equals P naught e raised to the power of rt. So here we know that P naught, which represents the initial population, is 4,000, and we are going to use this information, that is tripling time is 4 months. That is when t equal to 4, the population gets tripled. That is, we can say that P of t equals 3 times of P naught. So we can plug in this information into this model, and I'm going to plug in t equal to 4. So therefore we will have P of 4, and this equals, I'm going to keep this P naught as it is, e raised to the power of r times of t is 4. So let me put when t equal to 4, this becomes P of 4, and this equals 3 P naught. So I put P of 4 equals 3 P naught, and we have P naught e raised to the power of 4r. So we can divide both sides by P naught. When we do that, we get these two cancel, and we have 3 equals e raised to the power of 4r. We solve for r by applying natural logarithm to both sides. So when we apply natural logarithm, we get a natural logarithm of 3. This equals natural logarithm of e raised to the power of 4r. So using the property of natural logarithm, we take this power and put it in front. And when we do that, we get a natural logarithm of 3, and this equals 4r times natural logarithm of e. We know that natural logarithm of e, the value is 1. So I'm going to replace this quantity by 1. And this means I can just remove this factor, natural logarithm of e, because 1 times 4r is going to be 4r only. Now we solve for r from this equation. So this implies r equals, we divide both sides by 4 to get r. So it is natural logarithm of 3 over 4. And when we plug this into the calculator and approximate to 4 decimal places, we get r is approximately 0.2747. So we have determined the r is approximately 0.2747. We can plug this value of r into the equivalent exponential model. So I'm going to do that. So therefore, we get P of t. This is the equivalent exponential model, equals P naught, which is 4,000 e raised to the power of rt. R is replaced by this quantity, that is 0.2747 times t. So it is 0.2747 t. So this is the equivalent exponential model.